Educational Computing, a weekly half-hour focused on the educational application of the microcomputer and high technology. With the highlights of today's program, here's Tom Brown.
Thank you, Kay, and hello, everyone. Today on Educational Computing, Fred D'Ignazio will be talking with Craig Sturton and David Humphreys from the Children and Computers Project in Ontario, Canada. Lydia Copeland will be looking at Take One, an animation program. Jay Sivin has Tom Snyder back to continue their talk about problem-solving software. Joining them this time will be Marge Cosell from Sunburst Communications. And, of course, Ken Komoski will be here with a commentary about IBM's giveaway. Since we have such a full program, our news and views will be brief this week. We're seeing more and more interest in computer classes teaching word processing, databasing, and spreadsheets instead of computer language. This should bring more parents as well as students into computer training centers to find out what the computer can do for them. Keys to Responsible Driving is a software program by CBS to teach students the rules of the road. The program provides interactive instruction on rules and regulations in preparation for the Motor Vehicle Department's written test. A Chevrolet dealer in Wilton, Connecticut has purchased 10 sets of the software for the local high school as part of the dealer's community outreach program. Ever look at the other side of a single-sided disc and wonder, why can't I use that? Well, you can. You just need to make a notch on the opposite edge like the original one, and you're in business. There are some notchers for sale commercially, but you can make do with a paper punch and scissors. By the way, the backside of a disc is not a good place for important programs or data. Continue to put that on a good quality single-sided disc. The Academic American Encyclopedia is now on The Source. The fee will be $7.50 a month or $29.95 for a 6-month subscription. Either will offer unlimited searching for the time period. Grolier Electronic Publishing has announced it will be offering the encyclopedia on CD-ROM discs in the near future. For those who feel stuck with a TI-99 4A or an IBM PCjr, please note that new software for both machines is still coming out. However, you do have to get on mailing lists of companies who sell the software to keep abreast. Just because you don't see advertisements for these products in computer magazines doesn't mean they aren't out there. And now here is Fred D'Ignazio and his guests.
I'm Fred D'Ignazio, and recently I went to Toronto, Ontario, where I had a chance to learn about a new project called Computers and Children, which is being sponsored by the Ministry of Citizenship and Culture of the province of Ontario. Today we have with us the two gentlemen who are administering this project, David Humphreys and Craig Sturton. David, I'd like to ask you if you could just describe what are some of your goals and objectives in this project.
Well, I think our primary goal is access for children, and that can include, I think, children up to 65, although officially our mandate is from senior kindergarten to grade 8. And the access means having a meaningful contact with the computer, which is a little bit more than drill and kill. It's a little bit more than basic. It's being able to use a computer in the same nonchalant manner as you use a paper and pencil today. But remember that a paper and pencil is a part of a print culture and was very, very powerful in its time. And the computer is a part of information technology culture and is very, very powerful today. And so we're trying to bring all those things together with the children.
Craig, let me ask, how big is this project? How far does it extend?
Well, for, I guess, your audience, Fred, to get some kind of degree of scale, the province of Ontario covers 450,000 square miles. The border between Canada and the United States that through the province of Ontario is approximately 1,000 miles long. So it's fairly expansive, but we only have about 10 million people in the province, so it's large but sparsely populated.
And how many centers or projects are you trying to begin?
We were mandated to initially establish 230 centers across the full geographical scale, but we've also just recently had an addition to go to 330.
How many centers are in operation now?
At this point, we have 52 up and running.
David, what goes on at these centers?
Well, actually, the typical center is not typical because we're in Indian reserves, we're in children's museums, we're in a few libraries, we're in a lot of community centers, converted church buildings, We're in the basements of places. We're in an old farmhouse in Charlotte Lake. And the essential thing is that, for example, we're in a community school or an Indian school. The school gets to use the computers during the day, but they have to provide 2 hours of free access per machine, per child in the community through the week. And that's where the action really takes place. And you'll find children working on open-ended software. They'll be working with graphic tablets. They may be doing and driving towards CAD with some older child showing them how to do it. In fact, the children are the teachers in the center, and you've got a whole bunch of adults who are learners as they go along. So you've got teachers and parent volunteers, old age pensioners coming in to do work and things like that. So that would sort of describe the typical center.
I've heard that this is a very grassroots project. What do you mean by that?
We do not go out and parachute these centers into locations feeling that they should have it. They must first initiate a contact with our center. A simple telephone call usually is sufficient, at which point we come to the community and ask them to gather together all interested individuals, obviously educational leaders, principals of schools and so forth. We get service club members who are interested in the technology. We get librarians. We get just general citizens who want to volunteer and be a part of this. Once they have done that, then they begin a little process by which we show them what is going to be needed. Because although we provide the equipment at no cost, they must assume the responsibility for the ongoing operation. Just to, if I might add one other thing, is it's per computer per day, not per child in the community.
Oh, that's right, yeah.
Okay.
Yeah.
Sorry, David.
That's what I'd like it to be.
I've heard that the Ministry of Education has a computer project of its own. How do your activities and theirs work together?
I think we're going to prove to be an invaluable resource to them, both probably now and in the future, as we can do things which don't require curriculum committees. We're not bound by the traditional curriculum. We don't have to make reference to normative levels, because I don't think they exist. And so I think as time goes by, they're going to realize that we will be very invaluable to their future and their survival.
Do you two have any stories to tell about the kids or teachers involved in your centers?
Well, I was in a particular center just prior to coming to the conference here, and I was impressed by the enthusiasm which our coordinator in the center was referring to one student who was there. Now, this is a young adult who has a severe mental handicap, and he was operating at a functional level about half his chronological age. This individual had no means by which he could get any kind of successful communication with the outside world. Using a program called Delta Drawing, he had been creating some of the most magnificent artwork. And I had some examples that I showed at the session here. And his whole self-esteem had just risen, 1,000 times. It was magnificent. And not only, I wasn't talking to the individual, but talking to the coordinator. And I got that kind of feeling from them, so I can just appreciate what it was like in the flesh.
We have a center in Charlotte Lake, and a very old lady goes to it. She's about 70-odd. And she can't write because she's got severe arthritis in her hands, but she can work on the keyboard. And so this is at the other end of the scale. What she's doing is she's putting all her mother's recipes, all the things you're going to probably need when you get an outage, such as how to make candles and how to ret linen and things like that, and also how to bake certain kinds of pies, which you can no longer get in bakeries anywhere, and how to bake real bread and not this white gooey stuff. And she's putting that into a database, and then the community can use it. Also, we're encouraging the building of what you might call community databases. That is, the children start their own database, a database on friends with pets, say, and then it moves on from there. But because adults are coming in, they start putting their own records in, and then the whole municipality, the whole community becomes involved. And so ultimately, the community is going to be involved in its own data. It's going to be able to gather its own facts, and it's not going to rely on much larger bodies for that kind of thing. It's going to make it for a very healthier, probably a very healthier tax base or something like that.
Well, David and Craig, thank you very much for being guests with us on Educational Computing.
Take One is available for Apple II Plus, Apple IIe, and Apple IIc. Use of a color monitor with the program is recommended. The package consists of one diskette and an 80-page user's guide. Take One is a complex program that allows users to create full color animated images on screen. It's strictly a graphics production tool and was not designed with instructional objectives. The producer does not specify an age or ability range for intended users. The reviewers do not suggest an appropriate audience either. They do, however, warn that the program is sophisticated and requires concentration, patience, and considerable effort on the part of the user. A segment like this takes an hour or more to create. Take One offers a variety of animation activities. Each option consists of numerous graphic functions. There's not time to examine each of these features closely. We will try to get a sense of the software's structure and capability by using it to create a simple animation. Then we'll look at a more sophisticated example of the animation. Take One can produce and discuss the reviewer's assessment of the program. The scene editor is the heart of the animation system. It's where the individual frames are composed and put together to make scenes. First, we need to select an actor and a background from those stored in the program. Let's use the Mojave Desert. And pick Little Dugan. He's the cartoon character we saw with the program menu as our actor. Now we're ready to select the Shoot Scene option and begin work. This is the frame composition screen with the desert scene we selected in the background. The band of text at the bottom of the screen is the status window. The top line indicates which frame we're working on and the total number of frames we've created. The words at the bottom of the window are commands. The keys used to enter the commands are highlighted. Since we're just starting, we need to press A to add our first frame. The status window changes to say we're working on frame number 1. It also says to press the question mark key for help, which we need to do to find out what comes next. This menu lists all the commands for shooting and editing frames. The one we need first, since all we've got is a background, is C for casting or adding an actor. Hitting the question mark again takes us back to the frame editor, and pressing C brings up the name of the actor we loaded, which is added to the frame by hitting Return. To find out what to do with our actor, we press the question mark again, which takes us back to the list of commands. At the top of the screen are the Move commands, which we can use to position our actor in the frame. The group of keys on the right moves the actor up, down, left, or right 1 pixel at a time. The center group moves him 2 dots at a time, and using the control key with the same keys moves him 10 pixels each time. Going back to the frame editor, we can use the W key to move Little Dugan up to the line of the horizon, and the Control and A keys to move him to the left side of the screen, since he seems to be coming from that side. Next to the X and Y display in the status windows is the term Shot. It indicates the snapshot of the actor that's currently on the screen. Each actor has a series of snapshots showing different poses. By pressing the arrow keys, we can change snapshots of Little Dugan and make him appear to walk in place. Why don't we start with Shot 7. If a series of snapshots is repeated in sequence with movement, it becomes an action. By pressing the Y key, we can select from several canned or automatic movements for each actor. Let's have Little Dugan walk right. Once our actor and action are set, we are ready to create a series of frames. Frame 1 is shot when we press Return. Frame 2 is composed automatically when our predefined action changes to the next pose and position. By holding down the Return key, we can quickly create a series of frames that moves our figure to the middle of the screen. We can also change actions. Let's pick Jogger this time. And why don't we make Little Dugan hurry off the screen? Now, to see what we've created, we need to escape from the frame editor, use the F command to return to the first frame, and use the R command to run a preview of our frames. The status window lists other commands we could use to continue working on our scene. We could insert additional frames, edit those we just created, or delete any we don't need. The full screen can be revealed by dropping the status window. The main menu lists two other important options. We could select Actors and Actions to create our own characters and snapshots of their motions, or Pictures and Backgrounds to create new backgrounds. These features are much more complicated and indicate the sophisticated animation possible with this program. So does the following example. This segment is entitled Shuttle Discovery. It's a sample animation provided with Take One and was produced with the standard characters and backgrounds included in the program. The movie editor feature was used to create the special effects at the beginning and end and the transition between scenes. We are using the movie projector option to show the segment. Take One is recommended with reservations. The reviewers describe it as an excellent technical tool that produces impressive animation. Their reservations are about the program's complexity. It is time-consuming to use and difficult to learn to use. The user's guide offers 2 introductory tutorials, but consists primarily of technical information. This limits the program's value, particularly for use in schools. Students who are not highly motivated are likely to require a great deal of teacher assistance to avoid becoming frustrated. The reviewers recommend 2 improvements in Take One. They suggest that the producers provide more pre-stored characters and visuals with the software. We have seen most of the actors available with the program. The reviewers also suggest expanding the user's guide to enhance its instructional value. Include, for example, more introductory tutorials and hints for creating sophisticated animated sequences.
Hi, I'm Jay Sivin, and we're talking about logic problem-solving software. We're here at the World Conference on Computers in Education in Norfolk, Virginia, and I'm talking with Marge Cassell of Sunburst Communications and Tom Snyder of Tom Snyder Productions. I'd like to talk a little bit about how you go about integrating logic problem-solving software, or software that can help you engage in logic problem-solving teaching in the classroom. How do you see that this kind of software gets in the hands of teachers and they know what to do with it, they can use it, and they can use it meaningfully?
Well, we sort of see the computer, Jay, as setting up an environment in which the teacher can teach. Probably the thing that we have changed our approach in the last year is we had set up environments in which we felt teachers could teach, but a lot of people could not handle the environment because they didn't have enough background as to how to actually approach problem solving and teach problem solving. So now we're putting more support materials around it. What we consider support materials are student materials, that there will be something that the student can go through that will teach them about a problem-solving skill, and then something working on the computer, and then a follow-up that will take that problem-solving skill and try to relate it into writing or into mathematics or into other subject areas. Many of the activities that we have for the students are group activities that they may work with a small group of students, but making it a little bit more independent and then providing the teacher a guide to tell how to work with the student within that environment.
Maybe you could take us through an example of one program where you're building in this support structure.
An example of a program that we're doing this with is one that we have called The Pond. It does pattern recognition. So the first things we did in the guide for the student is we had the student look for some patterns. And we started with very simple patterns. We talked about what a pattern was. A lot of kids don't know what patterns are and what the elements of a pattern are. So they went through a basis where they look for a pattern, they look for repeating patterns, they look for visual patterns, they look for numeric patterns. And look for patterns in places around the house, in wallpaper, and then they went to the computer and they did an activity having to do with defining patterns and pattern recognition, and then followed it up after the activity with extending it on to patterns in language. There's consonant, vowel, consonant patterns that we have within our language. So taking that whole idea of patterns and showing students where there are patterns around them and how they can use patterns sometimes to solve a problem.
Tom, I know you've been doing a lot of thinking about how we should and should not use computers in the school, especially in the area of logic problem solving. Perhaps you could give me an idea of what you like about this use of the computer and perhaps what you don't like or what you would do differently.
I like it all. I think it's nifty to teach problem solving. Probably the area of integration that concerns me the most, which was just touched on, is related to the mechanics of the classroom more than the teacher training, which of course has to happen. But if you have a class of 25 kids and one computer in the corner, and every 5 minutes when a little girl blows up a diphthong bomb with an adverb and goes, "All right," and 24 kids turn around and look at that kid, then I would say you have a mechanics problem with the way the software is designed. It requires very good teaching to set up that kind of station teaching, you know, where their kids are going out to resource rooms or whatever. And a lot of teachers, especially more traditional teachers, don't know how to do that. And so we are always looking, as you are, for ways to have problem solving done in groups, which is not only efficient in terms of computer management, but that's a real powerful resource that we have in schools in the first place. Kids teach each other more than computers teach kids, I think. Or teachers teach kids more than computers teach kids.
I'm going to take a risk here. Okay. What do you think you might do if you sort of had the task for yourself or someone else gave you the task of teaching pattern recognition to a very young group of kids, and you had this concern of maybe 1 or 2 computers in a classroom? How might you use the computer?
Well, first I should say that, you know, if in the year 2000 every kid has a terminal at their desk, I'm thrilled with all existing approaches. In the short term, well, pattern recognition is one area that I will never be involved in just because I have no skill. I have no personal identification with that kind of problem. We are pretty inefficient in the way our company teaches problem solving because we often do simulations which are very open-ended. You don't know what you're going to learn when you sail across an ocean. We have some idea that the kids will learn something about the trade winds, and they'll learn something about the shapes of continents and how to use latitude and longitude. But as for the explicit problems that they will be faced with, it's different every time you sail, just like in the real world it's different every time you walk down the street. It works really well, though, whatever it teaches, and we're not sure what it is, but the investment is so high on the kids' part because they're so involved in this world that that is a method of problem solving that I feel comfortable with.
How would you justify that to the school board, to the parents?
I wouldn't. They would say, what about the demands on us to teach X curriculum? And I'd say, go ahead and teach it first before you do a simulation.
I see. And so the simulation would sort of be an extra.
It's an extra, yeah. I really think so. We're in a mess around phase that will last maybe 4 or 5 more decades, and then we'll know what we're doing and we can get down to some serious in-school software.
You've both given us something to think about, and I think you've both done a lot of good thinking about the subject. Thanks for being here.
Thanks.
Were you as surprised as I was when you heard about IBM's latest adventure with its ill-fated PCjr? When I saw a headline referring to IBM's giving PCjrs to schools, I thought to myself, well, that's a reasonable thing to do, and certainly the price is right. And even though Apple's The Kids Can't Wait computer giveaway in California hadn't worked all that well due to the lack of teacher training, it had helped to sell a lot of educators and parents on the idea that Apple was the educational computer company. So as I said, it seemed pretty reasonable to me that IBM would borrow the computer giveaway idea from the company that was consistently beating them in the educational marketplace. But when I read on, I just became puzzled, and so I decided to think more about it, and I did. And I found that I simply became more puzzled as to why IBM had decided to call what it was doing with its admittedly unmarketable inventory of 300,000 PCjrs a giveaway. It certainly isn't anything like Apple's The Kids Can't Wait program. The California schools that received computers under that program didn't have to buy a thing, but not so with IBM. If a school wants to participate in the IBM giveaway of PCjrs and receive one of Big Blue's unmarketable products, the thing to do is to purchase a sufficient number of IBM PCs. Now, I don't know about you, but calling a deal like that a giveaway simply doesn't wash. But wait, when I read on, I became even more incredulous. It seems to me that in its wisdom, IBM has attached a string to its giveaway. The string is that after agreeing to purchase the appropriate number of IBM's regular PCs, a school gets its giveaway PCjr only if it agrees that the PCjr will be used in special education programs. Then, after a year's use by the handicapped and the learning disabled, IBM says it's all right for regular learners to use the machines. Now, exactly what IBM means to communicate about the PCjr through this stipulation, I'll leave to the Freudians among you.
Funds for this program were provided by this and other public television stations, some state departments of education, and the Corporation for Public Broadcasting. Why watch educational computing? Well, for one thing, it's a very good program. Not that kind of program, a television program. We bring the world of educational computing into perspective for you, with software evaluations, interviews with computer specialists, expert commentary, and feature stories about this fast-changing field. Let us bring it to you each week on Educational Computing.